In this video, I want to have a look at dividing an interval into a given ratio. So we already know that if we want to divide an interval in half, we can find the midpoint. And to do that, we have something called the midpoint formula. So if we want to divide the interval joining the point x1, y1 and that point x2, y2, we can do that by going x1 plus x2 over 2 and then y1 plus y2 over 2. But we don't always want to find halfway between the 2 points that we're given. Sometimes we want to divide it into a different ratio. So if we want to divide the interval x1, y1, x2, y2 into the ratio m to n, then the coordinates of the point that divides those is going to be this. So this formula is on your formula sheet. So we're going to have m, so the first part of our ratio, m times x2 plus n times x1 over m plus n, and then something very similar for the y coordinate. So this is really important that it's when we're dividing an interval internally. So what that means is that we've got a point A here and a point B here, and we've got the interval joining them. And we want to divide them internally means that we're going to have a point somewhere in between those 2 points. And the ratio of this section to this section is m to n. So I want to have a look at how we can prove that formula. So if we've got a point here that's A, x1, y1, I've got a point up here that's B, x2, y2. We want to divide that interval internally in the ratio m to n. So let's pick a point, say here, let's call it P, and we'll call it A, B. And we want to know what the coordinates of A and B are. So let's draw in a couple of right-angled triangles here. They're not very right-angled, but you can get the idea. All right, now we should be able to recognize that these triangles are going to have to be similar triangles because they both have this line as the hypotenuse. So they're going to have the same ratio of rise over run. So having a look at that, let's call this one m and this one n because we want that ratio of m to n. Because they're similar triangles, these, the side lengths in these two triangles have to be in the same ratios. So if we look at this length compared to this length first, then we would have a minus x1 as the length of this side here. So a minus x1 over, and then this one would be x2 minus a. And because they're similar triangles, that has to be in the ratio. We had our big triangle over our little triangle, so we're going to have that as the ratio of m over n. Now to rearrange this, let's multiply both sides by n and both sides by this x2 minus a. So we're going to have n outside of a minus x1 equals m outside of x2 minus a. Then let's expand our brackets. So we have an minus nx1 equals mx2 minus am. Then let's pull all our a's over one side of that. So we'd have an plus am equals mx2 plus nx1. If we factorize a out here, we'd have a outside of n plus m equals mx2 plus nx1, and then divide through to get a. So we'd have a equals mx2 plus nx1 over, now we're dividing by this n plus m. I'm just going to write that the other way around as m plus n instead so that it matches our formula. Now we could go through and do the same thing with this side over this side to find our y coordinate as well. Now the other thing we need to know is that if we're dividing an interval externally instead of internally, we're going to have the same formula, but we're going to have negatives instead of positives, so minus instead of plus. Now what that means to divide it externally is if we've got the points A and B and the interval there, to divide it externally means we're going to have a point lying up here somewhere, let's call that P. So we can continue that on in a straight line, and the ratio of the length from A to P is m and B to P is n. So the ratio of the whole length to just this length is m to n. So that's the difference between externally and internally. Now this formula here, you can prove that going through that same process of using similar triangles. So let's have a look at a few examples. So our first example asks us to find the coordinates of the point that divide the interval A and B. For part A, we want it divided internally in the ratio 2 to 1. So this is for A. We're going to have our point P. Now we're going to use our formula. So we're going to have M, which is 2, and N, which is 1. And then we've got our x1, y1, and our x2, y2. So we're going to have 2 times 8 plus 1 times 2 over 2 plus 1. And then we'll have 2 times 6 plus 1 times 8. Not 8, sorry, minus 3 over our 2 plus 1. And then we can simplify all of that down. So 2 times 8 is 16 plus 2 would be 18 over 3. And 2 times 6 is 12 minus 3 would be 9 over 3. And that will simplify down to 6 and 3. So the coordinates of P that divides it internally into the ratio 2 to 1 would be 6, 3. Right? And if we're dividing it externally in the ratio 3 to 2, we're going to have that same formula but with negatives instead of positives. So this time our M is 3 and our N is 2. So we're going to have 3 times 8 minus 2 times 2 over 3 plus 2. And then we're going to have 3 times 6 minus 2 times minus 3 over, well, hang on, that's not a plus, that's a minus, over 3 minus 2, which 3 times 8 is 24, so 24 minus 4 would be 20 over 1. And then 3 6s are 18 plus 6 would give us 24 over 1. So the point that divides it externally in that ratio is 20, 24. So that's having a look at dividing an interval into a given ratio.